Hi guys, welcome to video 40, and this is the second of two videos where we are looking specifically at the record data structure and how we make use of that in programming languages like Python. So before I crack on with the final demo, guys, I just wanted to cover and revisit some of the key concepts and terminology that we went through in the first video. So we started off by looking at the typical characteristics of a database table, and we said that when a database programmer sets up a database table, they will define the fields of the table. The fields will often be of a particular data type, could be integer, could be float, could be Boolean, could be string, and a variety of other types as well. And in some database languages you can also specify the maximum length of a field as well. So in other words, all of this is about making your database as efficient as possible when it comes to taking up space and memory when we come to use it. Now, none of those concepts, guys, gel particularly well with the traditional programming data structure of the array, because as you know, the array cannot cater for more than one data type, and naturally then we're not in a position to limit the individual lengths of individual data types either. So over a period of time, languages like Delphi and Pascal began to evolve and include as part of the feature of the language this concept of the record data structure. And in fact, when a Delphi programmer sets up a record data structure when they're writing a program, they do so in almost exactly the same way as a database developer would create a table with individual fields of individual data types of a particular length. Okay, so the idea behind the record data structure is to mimic as much as possible the type of structure we would get from an individual record which we might see in a database table, for example. So on this slide, guys, it says records from a database table or spreadsheet often comprise different data types. Absolutely. It's also the case that the record data structure can mimic the style of individual records and include the use of a unique identifier as well for each record, and that's something which I incorporated into the last demo. Okay guys, so what we said was, as part of the last demo, in this video I would look at ways in which we can work with a text file that contains delimited data, read that into a Python program, and then use the Python dictionary to mimic the idea of records and of a table to store those records in. And we said even though the text file doesn't have the original data types in place, this might be useful for you, because it may well be the case that with your practical programming project you will be reading data in from a file and writing data to a text file, and you may actually want to use all of the benefits that you can enjoy using Python dictionaries to mimic the idea of a record and also to mimic the idea of a table as well. So that's where we're going in this video. Our last demo then, guys, is to look at ways in which we can read data in and store that as part of a record data structure and a table using Python dictionaries. So let's crack on and do our final demo. Okay guys, welcome to this demo. I think if I put my cursor over the block comments, you should be able to read that a little easier. There we go. Okay, so just a summary there of what this program is designed to do. Essentially, most of it is standard file handling. So we're going to take a CSV formatted text file with delimiters in, and we're going to read in each line of the file. We're going to convert the string input into a list, which is the standard way that we do things. Then we'll take the values from the list and we will populate a record with those values, guys. So of course, as in previous demos, we'll be using a Python dictionary for that. For each of those records, guys, we will use that to populate a table. The table will also be a dictionary data type as well, or data structure I should say. And then at the end of the program, we're going to invite the user to input an account number, and then we're going to provide an output of all of the customer details for that account number. And just to show you the process that we've been through to convert the string data type back into a meaningful data type that would represent the data as if it were in a table, we're going to do a calculation on the average age of our customers in the table, guys. Okay, and obviously we need an integer data type to be able to do that. So let's run the program and I'll show you what it looks like. Okay, so the first thing that we're asked for is the search. Okay, so we've done all our file handling by that stage. So I'm going to put in a relevant or valid account number. And there you can see, guys, on the screen, it's printed out and quite nicely formatted all of the individual values for the record that it's found for that particular account number. And of course, that's Peter Smith's. Okay, and at the bottom there, guys, you can see a calculation for the average age of our customers as well. Right, so let's go through this, and for each block of code, guys, I will explain to you how the sequence of code actually works. Now, I have provided this, guys, as I said I would, in the relevant Schoology folder alongside the videos. So if you want to work on this yourself, of course, guys, you can download that as a text version, which you can convert to a Python file, of course, and play around with that to your heart's content. Okay, guys, so let's start at the top. What do we have? Let's zoom in. We have declarations of structures to start with. So I have declared an empty table, which is, of course, of type dictionary. And I've also declared another dictionary, guys, which I'm going to use as an initial structure to capture a record from the lists each time we go through and do our file handling. Okay, so we have two declarations of dictionaries, one for a table and one we're going to use for each individual record. Okay, and you'll see those used a little bit later on. So the next block down, guys, if I just zoom out, okay, the next block is essentially basic file handling. All right, so you will have recognized this if you are familiar with file handling and you've done a little bit of revision with the videos as well. You will instantly recognize the syntax here. So essentially what we're doing is we're opening the file, and the format for opening the file, guys, is with open, okay, name of the text file and then the mode, which is read, because we're not doing any writing, and then the nickname of my file, which is my file. And of course, guys, standard practice is before we iterate, we read in the first line, okay, and assign that to a variable which is record. Okay, so record is the first line that's read in from the file. That will of course be the equivalent of a record, but it's in delimited format, and it's a string data types, guys. Okay, so now we start our iteration. So here's our block of iteration down here. Okay, so we're looping through the file, guys, and reading in each record. So our standard condition, while not end of file, so in Python terms that's while record does not equal null, guys, that's here. And the next thing that we do is we strip off the end of line escape character, which happens when we read in text from a text file, guys. Okay, so we've stripped off that unwanted character at the end. Okay, and then what we've done is we've taken the string. All right, so record is a string data type, and it's the entire line that's read in at that point in the file, and then we split that so we can populate a list. Okay, so a list is called record list, and that's the string converted into a list. Well, of course, that's fine, except for the fact that we want to take the values in our list and use those to populate a record data structure, which of course is our dictionary. So the first thing that we need to do then is we need to unpack so that we have values for each of the items in our list assigned to individual values, guys, and then we can work with those, okay, to set up the values that we need for our record. So let me just zoom in a little bit, because I think we can afford to do that. If I just move this over, okay, and I can move this over as well. There we go. Okay, so this is the bit where we are essentially unpacking the list that we've just created for the relevant record in our file. Okay, guys, so here's the unpack, and I've unpacked all of the elements of the list, record list, guys. So of course that will be the constituent values from the table, signed up from the table from the file. Okay, so we have customer ID, account, first name, last name, email, phone, and age, guys. So exactly the same thing that you've seen in the previous demos. Okay, all created from the individual list. Okay, so what I'm doing here, guys, is I'm converting back from the string data type to sensible data types, and I've used a single line assignment to do that. Okay, so customer ID comma age then becomes the integer of customer ID and the integer of age. All right, so a single line assignment or a single line to do multiple assignments on the same line, guys. Okay, the rest of them are string data types with the exception of account, which is a Boolean. Now in the text version in the file it's yes or no. All right, so a really quick way of converting that to a Boolean equivalent in Python is just to do an evaluation here, which basically says, does account equal yes? All right, so if this record is yes, then account is given the value of true, because it's the result of evaluating a condition. All right, account will also be assigned the value of false if that's not the case, guys. Okay, so just a real nice one-liner to turn account into true or false from yes or no. Okay, so the next thing we do, guys, I've left a little bit of a space there because this is our block of code where we are essentially taking our individual items of data and we are populating a list with those. Okay, so let's just scroll down a little bit so you can see. All right, so this is our block of code where we are creating our record structure here, guys. Okay, so dict record, which is the empty dictionary that we assigned right at the beginning of the program, now gets assigned some meaningful values as a record data structure, guys. Okay, so you've seen this format before. There we have, of course, inside our slinky brackets, our braces, guys, are the actual values. We've got our key value here, okay, and together with the values on the other side we get key value pairs, guys. All right, and of course on the outside of that we have our syntax brackets, which we need as part of our assignment, guys. Okay, so we've got the circular brackets or curved brackets on the outside. Okay, so standard format, guys, and of course each of the values we have just got from unpacking our list. Okay, so it's nice, neat and easy way of converting data from a list straight into a record data structure. Okay, so we now have our first record populated. So we need to do something with that. So what we're going to do is we're going to take that record and we're going to use that to populate our table. All right, so here's the update syntax that you saw, guys, in the previous demo. So it becomes table.update, and then of course we want a key value pair. All right, so the same as we're doing here, it's just that we've got one of them. Now let me explain, let me just zoom in what these variables are actually doing here. So customer ID, what's this then? Well, the customer ID, guys, you remember in the previous video I chose to use the customer ID and use that as our unique value to identify each of our records in our table as a unique occurrence for a customer. All right, so customer ID actually is essentially the value that's been assigned to that variable, which actually already appears, guys, here. Okay, so the customer ID that actually appears as a value in the record, I'm actually sort of copying that out and I'm using that as our key value pair, all right, for the whole of the record. Okay, so we are adding to the table a brand new occurrence of a record, and there's the key value pair. The customer ID, okay, is our key. All right, so the actual value is a record structure in its own right. Okay, so that then gets added to the table, and of course with tables, guys, with dictionaries I should say, we don't have append, we only have update in order to add a new value to our dictionary or table. And then of course, last but not least, guys, we do need very easy to forget, guys, I do this all the time, is to remember to read in the next line, because we are still in our iteration, guys. Okay, and here, guys, you can see this is the point in our code where we end our iteration. If I just zoom out, that'll make it a little bit clearer, I think. So let's get rid of the boxes. All right, so let's zoom right out, guys. All right, and you can see that we have finished with our record data structure. We've finished with our iteration. If I just put my box up there, guys, can I zoom out a little bit further? Yes, I can. All right, so we finished with our while loop, all right, which is there. Okay, so we've gone through all of that. We've accumulated all of our records from the file, and for all of our records we have populated the table with each of those records, guys. And then last but not least, we've actually finished the file handling. Okay, so all of the file handling and reading of stuff and moving across into the records and table has been finished. Okay, so now we can actually start working with all of that data that we've accumulated, guys. Okay, so let me zoom back in and then we can scroll down a little bit. Okay, so this is the block of code where we're asking the user to provide us with an integer or integer style input, and then we're going to search. So some of this you've seen already in the previous demo. All right, so this is the bit here, guys, where we get the user input, and I've given it a name of account number. All right, now I haven't, if you noticed here, guys, I haven't converted it across to an integer data type, and there's no point yet because I want to validate the input before I do that. Okay, so I'm going to check the raw input from the user. All right, so I'm just going to use one of the Python is functions to validate the input. All right, so let's just zoom in so you can see that a bit more clearly. Okay, so once we've got the value in, all right, so I'm doing a condition and I'm checking using the Python dot function is digit, guys. Okay, I'm checking whether all of the user input is a text version of a digit, so they haven't put any alpha characters in. Okay, now if that's the case, then we process, and I've actually turned this into a negative, so I basically said if not, in other words, if this is incorrect and it's false, then we print out an error message to say sorry, but the account number must be actually be a number. Okay, otherwise guys, we can happily carry on and process the correct input from the user. Right, so this is the point then. Once we've checked our raw input from the user, we can then convert it across and cast it to an integer type, guys, which is what happens here. All right, so that's account number is reassigned a value which is an updated version of account number, which is the casted version to an integer. Okay, so simply changing the data type. Now what we want to do is we want to check whether the valid input from the user is still a valid account number, because it might not actually be in the table. So we're using that syntax again, guys, where we just use the simple Python in operator, the membership operator, and we're checking whether or not the user's account number is actually a record in the table. And we can do that because I chose to use the account number as part of the key value pair when we assigned the record to the table. All right, so it's got something to check against. Now if that is the case, guys, all good news. All right, so we've got valid input and we've got a valid account number to check on as well. So this is the standard approach, guys, which I suggested that you do. All right, you don't have to do this. All right, it just makes life a little bit easier. When you want to drill down and get access to the key value pair, just simply put items on the end. Okay, so we start off with the name of the table. All right, then in square brackets we put the key of the key value pair, and of course that's what the user gave us as the account number. All right, and then at the end of that, the syntax is .items, and that will make available to us all of the key value pairs associated with that record. Okay, so now once I've done that, I can do my first unpack. All right, so I'm taking the entire record, which has been recognized in the code as being the one that's relevant to the user input. Okay, so I'm unpacking it here, guys. All right, so I'm unpacking record, and I'm assigning individual values to individual variables. But of course, this, guys, is a key value pair. All right, we don't have a single value here. We've got two values. So if I want to go to drill down and pluck out the individual key and the individual value, I need to do that separately, guys. Okay. Now, if you look here, what I've actually done, if we look here, guys, I've used fprint formatting, and I sort of had forgotten this actually. It's a little bit naughty. So in fact, I haven't done a second unpack. What I've done is I've actually used an index value. All right, because basically we're working with the equivalent of a list. Okay, so once we're unpacking down to the key and value pair, the key value pair, I can actually access those using a 0 and a 1 index. Okay, because I've gone past the dictionary structure and I'm now specifically looking at a list structure. Okay, so I've chosen to do that in this particular demo. All right, so I can actually access using an index rather than unpacking. All right, and I've used string formatting, guys, to format a nice column style format on the screen. All right, now I'll just go through string formatting very briefly, guys. Okay, basically you put your value in a set of braces. Okay, and then you can define the width of a column using this syntax here. So what I've said is our first column must be at least 15 characters wide, and that makes sure that the second column along, which will be the value associated with the key, is pushed out, all right, by a standard 15 characters, and that's what formats each individual column, guys. Okay, you can play with string formatting yourself. It's actually quite nice to use and fun. Otherwise, guys, you don't need to worry about this. You could just simply print it out on the screen. It doesn't matter. Okay, so what I've done is for each of our assigned values from record, we've got two values. So I just said that customer ID at position 0, okay, and customer ID at position 1. Okay, and the reason I've done that actually, guys, is because unpacking just makes it a little bit messy to print out every single dual unpacked set of values. Okay, so it's actually easier just to put in a direct reference using an index here, guys. Okay, so I hope that doesn't cause any confusion. As I said, we're using indexes here because the data that we're looking at is in a list. We're not actually trying to access parts of the actual dictionary structure using index values, guys. Okay, we've gone further down than that, and we're actually looking at what essentially looks like an ordinary list with two values in at index 0 and 1. Okay, so you've seen the best of both worlds, I guess, with that. Right, guys, so obviously the else bit at the bottom basically means that we didn't find an account number. Okay, and of course I've had to convert it to string because account number now exists as an integer. All right, so in the print statement, I've had to cast it to a string data type. Okay, right. The next bit down, guys, the last bit is the bit that actually finds the age value in all of our records, and then tots that up, divides it by the number of records in the table, and then that gives us the average, guys. So let's have a quick look at that. Okay, so let's scroll down a little bit. There we go. Excuse me, guys. So on this occasion, guys, I have actually decided, rather than table.items, okay, because I'm only interested in values, I have actually used the values function at the end there rather than items. Okay, so if this is causing a little bit of confusion, guys, just ignore it. You could use table.items and then simply work with your key value pair. I've just filtered out all of the values, all right, and then what I've simply done here is I've said for records in table values. Okay, so that means basically what I've got here is the equivalent of a list, guys. Okay, and what I've done is I've said age equals age, and then I've used the standard syntax, guys, for accessing a value in our record using the key. All right, and you've seen this before, guys, in square brackets. Okay, there are other ways that I could do that, but this is just a nice, neat little syntax for accessing a value using the key of the key value pair, guys. Okay, so I'm saying find me the value associated with the key age, and that of course will be our integer age, our integer number. I'm totting up, guys, an accumulated total here, so age becomes age plus the new age. All right, age starts off as 0, guys, just outside our loop. All right, so that's initialized there, and then right at the end, guys, we've got a sentence that says the average age of the customer is, and we're doing the calculation on the fly, guys. Okay, so we're evaluating the actual average within the print statement itself. All right, and then I'm converting it to a string. So as usual, guys, with Python, we start off on the right hand side and we work from the inside out. So first of all, Python gets the length of the table. Now we can use that function on a table just like we do on a list. Basically, len of table gives me the number of records in the table, which I think is 5. All right, so that's 5. There's our age. Age divided by 5 gives us the average. Okay, and then Python comes out of the internal bit and moves to the left. It then converts it to a string. All right, so that ends up as being string 34.2, the float. Okay, and then of course we can concatenate that with our string literal at the front end of our print statement, guys. Okay, so basically that is our code in summary. So guys, please replay the video, pause it, use the actual text version of the code if you want to download that and use that in Python idle or PyCharm and have a play, guys. And I hope that demo has been useful for you. I will see you in a new video, guys.